Assalamualaikum. So in this video, I am going to present examples of passive sensors. The first one is the thermocouple and the second one is the photodiode. So the first one is the thermocouple. So the operation is a conductor generates a voltage when subjected to a temperature gradient, and then there is another conductor which also generates a different voltage under the same temperature gradient. The difference between the two voltages will be measured. So that voltage difference corresponds to the value of the measured temperature. Okay. So you have the two metal A and metal B, and both of them has a property known as the ZA'BAH coefficients. The unit is volt per Kelvin. Okay. So Kelvin is another unit of temperature. And normally the question will give you the temperature in degrees Celsius. So you need to know how to convert into Kelvin. Alright. So this is the equation to calculate what is V out. So ZA'BAH of metal A minus ZA'BAH value of metal B. And YSA minus SB, you look at the polarity of your voltage. Okay. So the reference voltage is known as a cold junction. So this reference voltage can be any value. It can be 0 degrees or it can be another value of temperature. Okay. So the question will give you the table of the ZA'BAH coefficients as shown in this slide. So these are the materials that can be used, and this is the ZA'BAH coefficient for each material, and the unit is microvolt per Kelvin. Okay. So take note on the unit, it's microvolt. Okay. So in the slides that I have emailed to you, there are a number of examples. So in this video, I'm going to show a new example. So a thermocouple made of iron and constant tan is inserted into a furnace whose temperature is 1200 degrees Celsius, while the reference temperature is held at 50 degrees Celsius. So what is the output voltage from the thermocouple? So you are asked to calculate what is V out. Okay. So if you look at the formula, V out is equivalent to SA minus SB multiplied with the difference in the temperature. Remember that this is the equation to convert from Celsius to Kelvin. So T tip is the measured temperature, which is the 1200 degrees Celsius. So you convert to Kelvin. Okay. And then it's equivalent to the T ref 50 degrees Celsius, convert to Kelvin as well. And then plus V out over SA minus SB. The SA is iron, and then the SB is the constant tan. And based on the table, the ZA'BAH coefficient for iron is 19, and the ZA'BAH coefficient for constant tan is minus 35. Okay. And then you can calculate what is V out. 1150 multiplied with the 54 microvolt, and you will get 62,100 microvolt, which is equivalent to 62.1 millivolt. So that is the answer for the output voltage. Okay. So the next example of passive sensor is photodiode. So basically a photodiode is a semiconductor device that converts light into current. Okay. The current is generated when photons from the light are absorbed in the photodiode. Okay. This is important. So basically photodiode must be connected similar to reverse biasing of a diode, because photodiode has this characteristic. So it can operate in two modes. One is the photovoltaic mode, another one is the photoconductive region, and this is the operation mode of your photodiode. These numbers here are the light intensity. It will provide constant current, but the voltages will vary. Okay. In your slide, it shows something like this, which is also the same, and almost constant current with varying values of your voltage. Okay. So at higher level, it will have a higher current. So you can see in this example, which is also in your slide, your photodiode is reverse biased because the positive voltage is connected to the negative terminal, and so when the light falls onto it, there will be a current called IP over here. So basically the photodiode current will go through this path and go through your RF. Okay. So this is because there is no current going into your op-amp. Alright. So V out is equivalent to minus photodiode current I multiplied with the RF. So that is how you can calculate the output voltage. Okay. So this is another example that I would like to show you. So a photodiode is connected in series with a 200 ohm resistor across a 0.5 volt supply, providing reverse bias to the photodiode. So you can see the power supply is making the photodiode reverse bias. So the voltage across the photodiode is reverse. Okay, so the question asks to calculate the diode current if the voltage across the diode is 0.12 volt. So it's very easy. All you need to do is you have to do KVL over here. So 200 ID plus VD minus 0.5, then 0.5 minus 0.12 is 0.38 over 200 ohm, and you get ID equivalent to 1.9 milliampere. So that is the value of the current through your photodiode. Okay, so this is how you can use photodiode. By having a light falls onto it, it will have a voltage. So basically the voltage across your resistor here will change due to the change in the voltage across your photodiode, and this depends on the light intensity. So thank you everyone for watching my videos on active and passive sensors. See you in the next topic for electronics instrumentations. Take care. Bye. Assalamualaikum.